Today, we're going to pull back the curtain on reality itself. We're diving into a mind-bending idea from theoretical physics that says the world you see, the world you experience, is just the tip of the iceberg. Let's get into it. Okay, think about where you are right this second. You can move left or right, you can move forward or backward, you can move up or down. That's it. Those are the three dimensions of space that define pretty much everything we do. Feels complete, doesn't it? And of course, there's that one other direction we're all stuck moving in, forward through time. So you take our three spatial dimensions, you add this one time dimension, and you get the four-dimensional universe we all know and, well, live in. But what if that simple, comfortable, four-dimensional picture is just wrong? Or at least not the whole story? What if the real structure of our cosmos is way bigger and way, way stranger than our senses can even begin to imagine? Well, this is the absolute bombshell at the heart of string theory. It says we don't live in a four-dimensional universe, not even close. It argues that for the laws of physics to actually work, we have to be living in a reality with at least 10 dimensions. So why in the world would scientists cook up something that sounds like it's straight out of science fiction? Well, the story starts with a huge crisis, a deep, fundamental conflict right at the heart of modern physics. See, on one hand, you've got Einstein's general relativity. That's the rulebook for everything huge and massive. Planets, stars, galaxies, the smooth, curving fabric of space-time. Then, on the other hand, you've got quantum mechanics. That's the rulebook for the super tiny, the wild, jittery, probabilistic world of atoms and particles. And here's the thing, both of these theories are incredibly good at what they do. But, and this is a big but, when you try to use them together, like to describe what's happening inside a black hole, which is both incredibly massive and incredibly tiny, the whole thing just falls apart. The math breaks, the equations spit out total nonsense, like the number infinity. Einstein's smooth universe and the jittery quantum universe just can't get along. So physics needed a peacemaker. It needed a theory of everything that could finally unite these two warring sides. And this is where string theory walks onto the stage with a radical new idea. The big idea is this. If you could zoom in on any particle, like an electron, way past what our best microscopes can see, you wouldn't find a tiny little dot. No, you'd find a minuscule, vibrating loop of pure energy, a tiny, one-dimensional string. Now get this. Just like a single violin string can play a bunch of different notes depending on how it vibrates, these tiny cosmic strings create everything we see based on their vibrations. If a string wiggles one way, boom, we see an electron. If it wiggles another way, poof, it's a photon of light. And if it vibrates in just the right different way, it's the particle that carries the force of gravity itself. The entire universe is a cosmic symphony. It's a beautiful, elegant picture, right? But this theory comes with a very strange, non-negotiable price of admission. For the math to work, for these strings to vibrate in just the right way to create our universe, they need a whole lot of room to move. You see, when physicists first tried to write the equations for this, it was a disaster. In our familiar three spatial dimensions, the math was just gibberish. It gave them impossible answers, like negative probabilities, so they tried giving the strings more elbow room. They tried the math in four spatial dimensions. Failed. 5 dimensions, still a mess. But then, when they got to 9 spatial dimensions plus 1 time dimension, 10 total, something magical happened. All the impossible, nonsensical parts of the equations just vanished. They cancel each other out perfectly. And this is the absolute key point. The number 10 wasn't just pulled out of thin air. It's the one and only number of dimensions where the math of string theory works. It's a mathematical necessity. Without 10 dimensions, the whole beautiful idea just falls flat on its face. Okay, so this of course leads to the big, obvious question. If these 6 extra dimensions are real, where the heck are they? I'm not seeing them, you're not seeing them, so what's the deal? Well, there's a really clever way to think about this. Imagine you're standing way across a field, and you're looking at a garden hose. From that distance, what do you see? You just see a line, right? It only seems to have one dimension, its length. But now, let's zoom in. Imagine you're a tiny ant crawling on that exact same hose. For you, the ant, reality is totally different. You can walk along the length, sure, but you can also walk around the hose. For the ant, there is a whole second dimension, that circular part that was completely invisible to you from far away. And that is the perfect picture of what physicists call compactification.
The idea is that while our 3 spatial dimensions got huge and expanded out, the other 6 are curled up on themselves, just like the round part of the hose, but on a scale so ridiculously small we could never ever see them.
So this gives us a whole new map of reality. We've got our 3 big spatial dimensions, our 1 dimension of time moving forward, and then wrapped up impossibly tight are 6 extra dimensions, curled into these fantastically complex shapes that physicists call Calabi-Yau manifolds. We can't see them, but the theory says they're there, and their exact shape dictates the fundamental laws of our universe. And you know, science doesn't just stop. By the mid-90s, there were actually 5 different versions of string theory. Then, a genius named Edward Witten showed they were all just different views of a single, even deeper theory he called M-theory. And M-theory? Well, it seems to work best in 11 dimensions. So the search continues. So it all brings us back to that powerful idea. Our perception of reality might just be a limitation of our scale. We are just like that distant observer looking at the hose, completely unaware of the tiny, curled-up dimensions right under our noses that could be secretly running the whole show.
Now, string theory is still just a theory, it's not yet proven. But it leaves us with this incredible, awe-inspiring question. If our reality does have this hidden architecture, what amazing cosmic symphonies are being played right now in dimensions we can't see? And what secrets of our universe are they writing?